Hi, and welcome back. So over the past couple of videos, we've been talking about intensive and extensive properties, and we've also been talking a lot about density. So what I want to do in this video is I want to more or less give you some notional data as if we had done an experiment on density. And we'll try to figure out the density of maybe a couple of different something. So let's say, actually, and this is actually normally, I guess, I know that this was one of the first labs that we did in my chemistry class, so I think it might be somewhat normal to do a lab like this. Let's say you had a beaker. Actually, yeah, I'll draw the beaker. So let's say, there's the beak. No, I guess it doesn't really matter that much to draw the beak, but we had a beaker filled with water, so filled with water. And what we were told to do was we also had a whole bunch of what's called metal shot, where there are these little spheres of some metal. And what we are supposed to do is we've got a whole bunch of this metal. They give you a bunch of this metal. And what we are supposed to do is we're supposed to try to figure out what the density is of this metal. And all of these different pieces of shot, we're going to assume that they're all the same metal. And we are going to try to figure out what the density is of this metal. And then, as you can see, I'll scroll down for a second. I drew in a little table of some different types of some different densities. And actually, you know what? I just realized I didn't write in the units. These are the densities of a few different metals that this metal shot could be. And the units are going to be in grams per milliliter. And I just realized I forgot to write that in, so I'll just take a second. Grams per milliliter, grams per milliliter, and grams per milliliter. So all this is going to be, I guess, the density or our density table of what, and the metal shot that we're given is going to be one of these four different kinds of metal, and we're going to figure out which one of those this metal shot is based on figuring out the density. And what we're going to do is we're going to do two different trials of this, and we'll say that the first trial maybe we'll put in half of the metal shot. We'll figure out, this will be our first trial. So first trial, we'll figure out what the density is of maybe half of the metal shot. And then for the second trial, maybe we'll just take all of the metal shot. So I'll say second trial. We'll take all of it and see if the density comes out to be a little bit different. So now you can probably think of what we're going to do to figure out the density, but essentially what we're going to do is, and I'll redraw my beaker maybe a little bit larger, is we had our empty beaker already. We had just water inside the beaker, and let's say that we had already figured out that the volume of water inside this beaker, and actually, you know what, I'm going to change this because you probably wouldn't be doing this with a beaker. You would be doing this with a graduated cylinder, let's say. So let's say you were doing this with a graduated cylinder, which is going to be much skinnier. And it's going to be, the reason you would probably do this with a graduated cylinder is because it would be much easier to read the volume of how much, to read the difference in volume based on how much shot that you put in. So let's say we started out and we already had water in this graduated cylinder. And let's say you knew that the volume of the water in here, you had measured out 10.0 milliliters. So we had measured out 10.0 milliliters with three significant figures. That was how much water we had in this graduated cylinder. And then for our first trial, so this is going to be our first trial, we put in some of this metal shot. So we put in this much metal shot, and I'll just draw in some metal shot. And before we put the metal shot in, we determined the mass of the metal shot. And we found out that the mass of this metal shot, and we're going to weigh this, I don't know if I've talked yet about analytical balances versus top-loading balances, but we measured this on an analytical balance, and therefore we got the mass down to, I guess it's 10,000ths of a gram. We got 4 decimal places, a 4 decimal place reading on what the mass was of this metal shot that we put in. We found out that the mass of this metal shot for our first trial was going to be 24.6857 grams. And then we also found out that when we put in the metal shot, the water level went up a little bit. Okay? And we found out that the water level went up to 12.8 milliliters. That was our new reading for how high up for how much more volume we had put into this graduated cylinder when we put in the metal shot. So now we've got enough information to figure out what the density of this metal shot is based on this first trial. And we're going to do a second trial in a second, but right now it's good to at least do our first calculation, before we move on to the second trial, just to make sure that we're getting just to have a good idea as to if we're doing the experiment correctly, what types of numbers we should get for the second trial, because if we figure out the density, and I'll figure out the density right now, we should expect a very similar number for what we figure out the density to be for our second trial to what it was for our first trial. Hopefully, I think I might be confusing you by saying that right now. So right now I'm going to figure out the density. So the density based on this first trial. And remember that density, I'll just write this up here, density is equal to mass divided by volume, okay? So we know what the mass is. We know what the mass is of this metal shot that we put in. It's going to be 24.6857 grams. And we also know what the volume is. And how do we get the volume? Well, this was the initial volume. This 10.0 milliliters. This was the volume before anything went into the graduated cylinder. This was the volume before we put that metal shot in. And then the volume that it was after we put the metal shot in was 12.8 milliliters. So therefore, the amount of volume that this metal shot occupies is going to be the difference. It's going to be the difference between these two quantities, right? So we'll just write that in. It'll be 12.8 milliliters minus 10.0 milliliters. And that's going to give us, I guess, this amount right here. This is the amount that the volume went up by in the graduated cylinder. So now let's probably you can see what this is actually going to be, and I'll just rewrite this again, that this is going to be 24.6857 grams divided by, what's 12.8 minus 10? Well, it's going to be 2.8 milliliters, right? So 2.8 milliliters, and let's go and get out the calculator. Clear it, and we get 24.6857 grams divided by 2.8 milliliters, and we get 8.81, and really be 8.82 grams per milliliter. But keep in mind, we can only report this to two significant figures, right? Because we only have we've got, how many? We've got 6 significant figures in our numerator of this fraction, but only 2 in our denominator. So we can only write this down to 2 significant figures. So we're going to say that our density we've measured is 8.8. So I'll write that down. The density for this first trial is going to be equal to 8.8 grams per milliliter. So this is our first trial. And this is going to be, and so now we've done our first trial, and hopefully we'll be able to see if we get some insanely, and I'll write this down, this is our first trial. And the important thing to realize, and hopefully figuring out density isn't that challenging for you, but the important thing to realize in these first few labs, and this is probably something like what your first lab might look like in a chemistry class, the important lies when you're doing these experiments is more that, okay, we did this first trial and we got a number. We got 8.8 grams per milliliter. And so now when we do our second trial, the very first thing we should at least have a sense of is we should expect numbers like this. We should expect something at least close to 8.8 in our second trial. If we don't get something at least close to 8.8, we can be somewhat relatively sure that we messed something up, right? Because, density, as we've been talking about in the past few videos, does not depend on the amount of stuff that we measure. It does not depend on, the fact that, for this first trial, we only figured out the density for half of our metal shot, and for the second trial, we figured out the density of all of the metal shot. Our density numbers shouldn't change that much. So we should, for our second trial, get something very similar to this 8.8. So actually, I am now going to scroll over to the other side of the screen. There we go. So we can still see our first trial, I guess, right there. And we are going to say for our second trial, so our second trial, we washed out our graduated cylinder. And then we measured out water into the graduated cylinder. And we measured out as close as we could get to 10.0 milliliters into this graduated cylinder. Hopefully, I think that should be enough. And we're just going to pretend that, when we put in the metal shot, and you can hopefully see that it's important when we pour in the metal shot that all of the metal shot gets completely covered with water. If we have metal shot, sticking out of the top of the surface of the water, we're not actually measuring the density of all the metal shot. So hopefully you can see that. But we're just going to imagine that with 10 milliliters of water in our graduated cylinder, we are able to completely cover all of, and actually, you know what, I'm going to change this. Let's say instead of 10 milliliters, let's actually say we had 20 milliliters for this second trial. So we filled up our graduated cylinder, and we'll say that, maybe we filled it up a bit more. We filled it up with 20 milliliters of water. And so we filled it up with 20 milliliters of water, and then we took all of our metal shot that we were given, and the drawing is going to look pretty similar, but let's just say we fit a whole bunch more metal shot into this graduated cylinder. And before we put in all of that metal shot, we found out that the mass of all of it, of all that we'd been given, was 125.8263 grams. That's how much all of the metal shot. That was the mass of all of the metal shot. So and maybe you can see, I know I said that we were going to take half of the metal shot for our first trial. And you can probably see, it's more like we took a fifth of the metal shot. So it's more like if our first trial was actually something like erase that and say like maybe our first trial was maybe something more like that amount, and our second trial was going to be all of the metal shot. So our mass for the second trial is going to be 125.8263 grams, and we put that into our graduated cylinder, and the water goes up by some amount. It goes up by some amount, And then we're going to measure the amount of water overall that's in the graduated cylinder. And we're going to find out that it is going to be 34.0 milliliters. That's how much the water went up by inside of our graduated cylinder. So again, we're going to figure out what the density is. And remember that density is equal to some unit of mass divided by some unit of volume. So we've got our mass. We've got 125.8263 grams. And then, again, we're going to divide it by the difference in our volume. So we're going to divide it by 20.0 milliliters minus 34.0 milliliters. And what does that actually come out to? That would be 14 milliliters, right? It's 20, or actually I wrote that wrong. It should be, sorry, I wrote these backwards. That should be, sorry. Had a brain malfunction right there. Just erase that real quick. Okay, there we go. Sorry about that. So this should be our final volume, 34.0 milliliters. Subtract out our initial volume. Subtract out our 20.0 milliliters. And now you can see what the change in volume was when we put the metal shot in to the graduated cylinder. It's going to be 14 milliliters, right? So I'll just write below. We've got 14.0 milliliters. And so now, what's our density going to be? Let me go and get our calculator out. Clear it off. And so now we've got 125, so 125.8263. That's how many grams we have, and we're going to divide that by 14 milliliters. So there we go, 14 milliliters. And we get 8.98. We get 8.98 for our reading of density. Let me actually write that down. And how many significant figures do we have? We've got 3 significant figures, right? Because we've got, how many? We have 7 significant figures in our numerator, but we've got only 3 in our denominator. So we can write down 3 significant figures. So we can say that our density is 8.99. So our density, for second trial density is going to be equal to 8.99 grams per milliliter. And that isn't, that might not be it's at least close enough. It's at least, you might have different standards in your chemistry class for how close you should be getting density. And maybe I should have, in the next example, maybe I'll do one where we actually get a little bit better numbers for our density. But this is, you can see that we got numbers that at least make some type of sense. And maybe you might want to, if you got numbers like this, you might want to go back and do another trial and maybe refigure out the mass of the metal shot that you were given and do another trial where you figured out the volume that it occupied. But for right now, for our purposes, this is going to be okay. So if we say that we have 8.99 grams per milliliter, and then we also have 8.8 grams per milliliter, let's just figure out what the average of those two would be. So we said we had 8.99, and then add that to 8.8, and we're taking the average, so we're going to divide by 2, and hopefully I'm not confusing you. I'm just averaging these two different values that we got for our two trials. So I'll just go ahead and get the calculator. So we have 8.99 plus 8.8, divide that by 2, and we get 8 that would really be 8.90 for our average density. Just write that down. So density average is going to be 8.90 grams per milliliter. That's what we've, I guess, figured out in in this experiment. And let's that close to anything on our table that we had at the beginning, our table of different densities for different metals. And we can see that it kind of is, right? It's kind of close to, or at least it's approximately what the density would be for copper, right? So now, and we could say that maybe we would go back and do another trial and see if we could get this number to get a bit closer to what the accepted density is for copper. But you can hopefully also see that we can say with reasonable certainty, we can say with at least reasonable certainty, that the metal shot that we were given, that this metal shot we were given, is copper. So anyway, and we did that completely by figuring out the density. So anyway, that is a little bit of an example of what your first lab in chemistry might look like. So anyway, hopefully you found this at least somewhat useful, and I guess I'll see you in a future video.